duty is to remove the misconception. And as Prof said, we have, during our teaching, questioning and answering forms greater part of our teaching. We always ask questions. Whether we are using teacher-centered approach or student-centered approach, you must ask questions. So we have bad questions and good questions. A question can be good depending on the level you are asking that question. For example, you ask kindergarten pupil that why is it that it is 10 a.m. here, but Nigeria it is 11. Look, you ask kindergarten such a question. It doesn't know how the latitudes and all those things work. But this question could have been asked probably at DHS level. So that one becomes a big question to that student. And because of that, you throw the student out of the class. And even to ask a question, you need some minutes or time before you allow the student to answer. So all those things become a quality a teacher must possess in the class. Now, I myself am harboring some misconceptions, and I want some of you to help me, especially because all of you are physics students. Now, when do you say a body is moving in a linear motion? Linear motion. Is that right? Is my question correct? You know, it's very difficult to answer because I've omitted a word, uniform motion. Have you seen it? So my first question was the type of question I threw at you. Now this one, when a body is moving with linear or uniform linear motion, what does it mean? What makes a body to move? And you tell a student that no, this body is moving with uniform linear motion. What is the condition? We are all physics students. And the next question is, when do you tell a student that a body performs a circular motion is performing a uniform circular motion? What will be the condition for the two to say that this is a uniform linear motion? That's why I teach. Always ask questions first to attract your attention first. Yeah.
For a body to be in a uniform linear motion, must cover equal distances in equal time intervals in a straight line.
I'm sorry to say you are wrong. Have you seen? And that becomes, if let's even help you by saying displacement, equal displacement, equal time interval, or equal distance, equal time, that becomes a constant speed or uniform speed. But when you use displacement, then we shall call it uniform velocity. But you don't use uniform velocity to say that a body is moving with a uniform linear motion. Have you seen? These are misconceptions, and some of you have demonstrated it. Rather, it is based on, have you seen? So all uniform linear motions, acceleration is constant. Is that all right? Which means that equal changes in velocity in equal time interval, that makes a body to move linear, uniform linear motion, but not the velocity being uniform. It's the acceleration. Is it all right? You are I've confused you. That's why always when you are given a problem with a uniform linear motion, you're always given acceleration. Take uniform acceleration to be Don't you hear that? And take uniform acceleration to be 2 meters per second squared. But if acceleration is varied, it is no more called uniform acceleration. Yes.
They don't say take uniform acceleration. They say take acceleration.
which is something difficult to explain to students. Or assume. The correct word assume. Is it all right? Because it's not in reality. Assume. But when we say, what about uniform circular motion? A body is in uniform circular motion. Oh, I'm making this class hairy. Uniform circular motion. Uniform circular. Okay, to help you, the uniform circular motion is based on uniform speed, constant speed. It's based, I'm using the chain, it's based on constant speed. They say that a body moves in a circular motion with constant speed, yet it is accelerated. Is it all right? So the uniform aspect is based on the speed. And when you come to linear motion, the uniform is based on acceleration being uniform. Is it all right? Because when you are in a circle, you are moving in a circular motion. At every point along the curve, the speed is constant, but the velocity at various points are different. Is it all right? Because velocity is a vector quantity, it's made up of magnitude and direction. And the magnitude aspect of the velocity is the speed. And the direction it is pointing, added to the speed, makes it a vector quantity. So at every point on the circular motion, the direction of the velocity is tangential. So, right, so that when the centripetal force holding you is cut, you have to cut. Is it all right? Yeah. That's why when you are moving in a curve or roundabout, I will advise you to take the inner part. Is it all right? Because if you are outside and the car arrives at the roundabout and the velocity it is holding or speed it is holding does not match the friction between the tires and the road, it will not be able to negotiate. And the only thing is that it means that the speed you are coming with cannot match the centripetal force required to keep the body, and therefore you can't tangent. So if you are outside, you are likely to be knocked. But if you are inside, there's no way it will turn the economy. Now, with this explanation,
I'm sorry, I didn't call you out for that one. I just wanted to know, can we put it in a different form by saying that the magnitude remains constant, but the direction of the velocity changes?
Yes, that makes it a different velocity. You see, it can be different from 3 scenarios. 1, magnitude can be the same for the 2 bodies, but different direction. You are not having the same velocity. You can have the same direction, but different magnitude. Also, there's different velocity. Then you can have the third one. Both the magnitude and directions are different. I don't write here. And possibility to achieve a uniform velocity means that one condition that it must be on a straight line. It's all right. It must be on a straight line. It is the only straight line which gives you a specific direction. And therefore you have achieved your direction. And therefore you can control the magnitude by keeping it constant. And therefore your velocity will be uniform. But if you maintain the constant speed, but the path is crooked, you can never have constant velocity. At least clear here. So the first condition is that to get uniform velocity, you must be on a straight line first. Okay, I think I've answered